Good morning. Here we discussed about the machine learning on the diabetes data. We import the library NumPy, Pandas, Seaborns, and Matplotlib, which is required for the machine learning and plotting diagrams. The diabetes CSV data files is downloaded from the internet, and we can read in the Pandas. So we get the data like this ones. It have a total 768 rows and 9 columns. Right? So which are the futures? So we can retry using our data dot columns, right, which is display our futures. What is the size of the data? So it is a 768 by 9. Now over here we find out the number of diabetes patients. So in our futures of outcome, we have the 500 as a 0 means no diabetes and 268 patients as a diabetes. uh, to just visualize the data related with each other. Over here we can draw the diagrams, right, related to the we make the using the group by, right, of outcomes. So out of 268 patients, the 2550 is the age of the is a over the nearest to 20, when over the nearest to 80 or 70 is a very less. So it is a relation between our outcomes and the futures. These ones related with the which one and these ones. That means age shows the in the small age the diabetes are very large, right? The BMI, the BMI for the what? For the our it is related with the middle to 20 to 40s, right? Blood pressure is in normals and diabetes, right? The diabetes pattern functions is lower than high. Glucose is nearest to 100 and high, and insulin is nearest to 0 than high. Pregnancy zeros and highs, and again screen thickness is nearest to 0 and high. So these are the different relation related to the outcomes. Now over here we check the data is null or not. So normally it is indicate the 0, that means in the every feature we have the some data. For the data cleaning means we describe the data, so we find out that like that this one minimum is a 0 value, which is not possible in the blood case screen test. That means it is a wrong data, right, like this ones. So we just filter out this data as are away, give blood pressure is 0, which is maybe incorrect. So what we should do, we count the total is 35 records out of this 10 to 800 records. So our target is to drop all this data. So we also calculate the similar features for the other, right? So these are the some figures which is indicate the zeros while in the cells, which is incorrect. So we just filter out the data, right? If we have the video, then we drop the rows, otherwise we take the rows. Now these are validate data, and on that data we apply our different models. We don't know which model is working better, so we take the some models: K-neighbor, SVS, logistic, precision, distribution, gradient boostings, random forest, and we apply the every model, right, and we can compare the accuracy. Over here first we have the data, so we split in the two parts, and for that we use the sklearn model selections for the training and testing splitting. These are the number of future names, right? We just take the outcome as our target columns. So X is our futures and Y is our target column, right? So we split using the train split functions from the sklearn training splits, right? The for XY is the futures, right? Our targets themselves. So that means we take receive the X train, X test, Y train, Y test. We just put the because of the warning, warning. Over here we just iterate the each model, right? Train the each model for our training data, and then we can apply our testing data and find the predictions value, and then we compare the our right accuracy score related with the our actual value y test and our predicted value, and we can edit that score. And these are the score values, and we also highlight this value in the bar graph. It is our last value 0.7 is the highest value. We also use the k-fold cross validations for that purpose. So similarly, we apply the each for the each model k-fold, right? So it is a validation score of the accuracies, the scores, and we similarly display the scores. It is again the last one is the highest accuracy plot. Okay, thank you.